as you set an issue here, what do you see as the basic research models in this totally different world a decade out?
I think it's a wonderful question and very difficult to answer. I think, first of all, you said it correctly. You said models, because I think we're going to see a proliferation of worthwhile models, that there are going to be more kinds of models than we're used to. And I think the drivers of those models are going to be somewhat different from the ones we're used to. The idea of the individual investigator coming up with hypothesis and testing will continue to be incredibly important for much of biological research. But for some of the applications that we're talking about, first of all, it's obviously going to be multiple centers, et cetera, but some of it is going to come from, in fact, the participant community. Clearly the case in rare diseases, we're seeing that already, where people aggregate individuals and families with rare conditions and basically go to researchers and say, here's some research that you can do now. We're going to enable you to do that. But we want to be more than passive. You know, we're not just going to put out our arms and let you draw blood. We'd like to be involved in deciding what are the research priorities, how information is going to be used, what's going to happen if drugs are developed based on this, who is going to have use of those drugs, at what cost, et cetera, et cetera. So I think it's going to be much more of a partnership than it is now. I think clearly the first change in terms of genomics is really going to be the availability of sequencing. That one can think, you know, with the amount of time it takes to get a research project off the ground, the age of GWAS studies done the way we're doing them now is almost finished. Just started. It's almost finished because soon it will be complete sequencing. Already people are asking, well, gee, should I go to just complete exon sequencing anyway? I mean, how do I do it? Within a few years when the price gets low enough, if it's $1,000, why waste time and money talking about, you know, let's just get all the information. But the
And new at noon, should society or government step in when it comes to changing the genes of a child before birth? That's the question high school students in Harrisonburg are discussing today. It's called transhumanism, or altering the human body through biotechnology. Award-winning journalist and author Ronald Bailey analyzed the ethics of the question. 8 high schools participated in the 16th annual event. Professor Myron Blosser says students will be confronted with this issue because of the new technology.
Once you know where a gene is, then that opens up the possibility for manipulating that gene, cutting, pasting, changing. And so parents will eventually have the options of manipulating their DNA prior to having children.
Blosser says intelligence, eye and hair color, history for disease, height, sex, and athletic ability may be changed before birth. However, it may present issues such as food shortage, overpopulation, or even religious conflicts.
Well, some big news for mothers-to-be. They may soon have a newer, safer alternative to the amnio, and it could help predict whether their child will be born disease-free. Dr. David Smati from our Medical Aid team is here with us this morning. Good morning to you, Doc. This is interesting. Millions of women in this country have had the amnio to find out if their child is likely to have Down syndrome, among other things. Now there's a far easier way to tell that. What is it?
It's a very exciting test that's coming out of China, and it's a simple blood test where the big news here is that they were able to really detect the genome and the whole map of the gene for unborn child in mom's blood. So instead of doing amnio, and the risk of amnio is minimum, but there is a risk of miscarriage. Now we're able to really take a simple blood test from mom and be able to really map the entire gene of that unborn child, be able to detect multiple tests, Down syndrome, thalassemia, and other genetic disorders. So it's a big deal. This test is being done between 9 to 12 months of pregnancy. It's fairly safe, and it's going to be used hopefully in the future.
I see the only downside is you could have more women worried now because they know a lot more. But moving on now, a new diet pill. It's called Contrave. It's been approved, but you say maybe not the best technique if you want to lose weight quickly.
You know, I read this extensively, and I also covered the whole story about Meridia. So I'm having a mixed feeling about these medications. Now, right now, the only FDA-approved medication we have is Xenical. Xenical, it prevents the absorption of fat. So that's sort of safe, even though there are some liver toxicity with that and so forth. These medications, historically, they have major side effects of cardiac, stroke, increasing blood pressure and palpitations. This particular medication, Contrave, which was approved by 13 and 7 votes, is a combination of antidepressants and also medications that are used for narcotics and alcohol. And it works, but the side effects protocol is not there yet.
Not something you're overwhelmingly behind. Here's another technique if you want to lose weight. New research shows that if you imagine eating a food before you actually consume it, it might help you not eat that, whether it's M&Ms or in my case a bacon, egg, and cheese sandwich. How does this actually work?
Now, this is actually a fun study if you think about it. They looked at 51 participants and they cut them into 3 different groups. The first group...
This is a baby. A baby generating data in a neonatal ward. Every heartbeat, every breath, every anomaly, from over 1,000 pieces of unique information per second. Helping doctors find new ways to detect life-threatening infections up to 24 hours sooner. On a smarter planet, analyze the data and you can predict what will happen faster. So you can do what they're doing in Toronto and build a smarter hospital. Let's build a smarter planet.
If you're a student, say a specialty called embryogenesis, in other words how the baby grows, then it becomes pretty clear that babies, or any living creature, they get built. They're built. So long as you know how to put those atoms and molecules together in the right way. So in a sense, in every cell in our body, if you look at the DNA, is the solution to generating an intelligent, conscious creature. So we know, in theory, we know the solution is out there, just waiting for us to discover. How long do I think it'll be before there are conscious machines?
Man has described himself in many ways. But if we concentrate on man in relation to his control over his environment, no description is more apt than the description of man as a tool-making animal. And in the short history of mankind, the majority of the tools which man has made can be thought of as an extension of his muscle power. That is, the ability to perform work faster and in greater quantity. However, in the mid-1940s of the 20th century, a different kind of tool was invented. A tool for extending certain of the powers of man's mind. This tool is the electronic computer.
Well, the word revolution is used very freely these days, and yet I think there's some meaning to the words the computer revolution. We have got an increase in computers of 1,000,000-fold, decrease in costs by 1,000, as we said before. This is a very real change. But the question still arises, will this revolution continue? It seems to me, in view of the political situation in the whole world, that no responsible group can oppose the coming computer revolution. Therefore, it seems to me we have a real one which will continue.
Yeah, robotic machines haven't really taken off in the way that people in the 50s and 60s thought they would. By now, we were supposed already to have human-level intelligence, not to mention intelligent house cleaning devices and so forth. And it's really taken much longer than people thought. We didn't have even the hardware capacity back then to create that that level of intelligence, and of course not the software capability either.
Now, those of you who have PCs and have had PCs for, say, the last 5 or 10 years, pretty well all of you will be very conscious of the fact that each model that you get, the capacity is increased, like it's faster, there's more memory, and it's more or less the same price. This phenomenon is called Moore's law. Moore is a person, Gordon Moore. He was one of the founders of the microchip company, Intel. He noticed a trend. The number of transistors that were being put on these integrated circuits, these ICs, was roughly doubling every year or so. And so he wrote about this. He wrote about this trend. And this trend has been going on for 40-odd years. And it's thought it will continue for about another 20 odd years or more. And so, I mean, just common sense says if you take any number and you multiply it by 2 times 2 times 2 times 2 times, eventually you'll get a huge number.
Well, Moore's law is just saying that every 18 months so the technological power doubles, and that's been followed for many, many years now, and despite people saying no, it's not going to be followed next year or the year after, it always happens. I think it's looking in terms of brains. Moore's law is providing us with super intelligent brains. It's saying that in 10 to 15 years time we are going to have machine brains with processing capabilities much more powerful than the human brain.
If in the 30s you met somebody, say you get some boffin, some egghead if you like, speaking on the radio in the 30s, saying pretty soon, 5-10 years into the future, it will be possible to build one bomb so powerful that it could wipe out a whole city. Well, most people would just laugh at it, think the guy's a nutcase. But
Mapping and patenting of human and animal DNA, and the genetic engineering of human, animal, and plant life. They are also developing chemical, bacteriological, and psychological weaponry, as well as tectonic and climate weaponry.
Goats, sheep and rabbits are making their contribution to modern medicine near Moscow. The animals are helping pharmaceutical companies produce drugs to treat diabetes and cancer. It's a groundbreaking science known as transgenic farming, as RT's Sarah Firth discovered.
Just how do you milk a rabbit? More importantly, why would you want to?
The genetically modified rabbits produce a very valuable drug in their milk, which is used in treating cancer.
Here at a scientific research centre on the outskirts of Moscow, these animals are aiding scientists in cutting-edge research. Welcome to the pioneering new world of farming pharmaceuticals.
This is where the animals are kept. Now these ones are ordinary rabbits, but if we go through into the next room, and you've got the transgenic or genetically modified ones. Now it's these guys that are proving so vital in the discovery and development of new treatments for diseases.
Whilst it might sound strange, the milk of transgenic animals has already been used to successfully treat patients, and it's not just rabbits. Around the world, traditional farming is now morphing into biofarming. Pharmaceutical companies are now turning to other domestic animals for new ways to produce drugs.
It's a breakthrough in pharmaceutics. Now we want to get to the point where we can have cows and goats producing this same drug in their milk.
At the moment, this research centre doesn't have the funding to produce more than a few other genetically modified species. But rabbits remain their main source of research. Regulatory bodies in the EU and the US are slowly starting to allow drugs produced by transgenic animals onto the market. But it's slow progress. In Russia especially, a lack of guidelines and solid regulation in this area mean it remains a controversial issue.
We feel that playing with genes could be dangerous for animals when people haven't fully studied all the hereditary mechanisms.
From cute pets to resource providers, as biofarming continues to grow, what these guys produce could soon very well end up in your medicine cabinet. Sarah Firth, RT, Moscow.